We are now looking at target 1.5. Our master learning objective is I can use proportional parts within triangles to solve for the missing pieces of the triangle. Okay. So we're going to look at two theorems. The first is the triangle proportionality theorem. Okay. And the triangle proportionality theorem states, there we go, that's what I want. If a line is parallel to one of the sides of a triangle, then divides the other sides, the other sides into proportional segments. So, our example, if here's my parallel sides, and I always start at the point that's not part of those parallel sides. If I go B to E, it's a B, not a 13, B to E, over, and then E to A. That's going to equal, and then same thing, I just start at that point and go B to D, and then DC. Right? Okay, so again, it's just another way of setting up, another quick theorem. This is, again, a shortcut for that this triangle proportionality theorem. I could, like we did before, take these triangles apart, right? But if I'm just comparing these sides, then I don't have to. I can use this shortcut. The biggest part that students get wrong, and we'll kind of look at this more in class as well, is if I'm trying to find the length of like one of these parallel sides, I still have to take the triangles apart. Okay. All right. So let's look at example 1. Use the triangle proportionality theorem to solve for the missing, or to solve for the variable. So again, I'm going to start, here's my parallel sides and the point, right? And I like to go down the line from the point. So here it's 18 over 6. And then down the line from the point, x plus 22 over x plus 2. Now I'm just attempting to solve this. And so I'm going to put my parentheses. And now this is a problem we know how to do. I have 18 times x plus 2. And then 6 times x plus 22. I'm going to distribute with both of these, right? So I have 18x plus 36 equals 6x plus 132. I have x's on both sides, so I'm going to get rid of this 6x. So I now have 12x plus 36 equals, right, those cancel. I'm going to subtract that 36. I now have, we're going to just go over here, just running out of space. 12x. These cancel. And I get 96, I believe. Now I want to get rid of that 12. X equals 8. I'm trying to do some of the math in my head. So again, you can always use a calculator, but and then we get x equals 8. So again, once we get to here, it's the same, right? It's just now we have a shortcut rule for how we can set up that proportion. Looking at our second one, if I want to use this same rule, right? Here are my parallel lines. Parallel line and parallel line. So here's the point. So if I go down, I'm going to do this side first. I have 3 over 9. And now for this side, I have to be very careful because this is where my x is, right? The question mark. And then I have to figure out what this side is. Okay. So this side is, the whole length is 20, but I already did the x. So this is actually 20 minus x, right? I don't want to include that x part. So here I should have x over 20 minus x. So then, I have 3 times 20 minus x equals 9 times x. So I have 60 minus 3x equals 9x. Add 3x. 60 equals 12x. Right, because those go away. And then divide by 12. So this would be 5 there. Okay. So be careful with these ones when you have that whole line across. I could do this problem a whole nother way as well. So I'm just going to kind of show it over here on the side. I could do it how we drew the 2 different triangles, right? So I'm going to look at my small triangle, which is the x, to the big triangle, which is 20. And then I could do the small triangle with this 3. And now this is what we were doing to the big triangle, which is 12. Now this is actually an easier problem to solve. We get 12x equals 60. And then x equals 5. Done. So depending on what you're given in your triangle, if it looks more like this or more like this, you might want to set it up differently. Should I actually use this triangle proportionality theorem, or should I separate the triangles? Okay. Again, it doesn't really matter which one you use. We got the same answer. One just meant you way quicker. Okay. But for here, if I tried to figure out these two separate, I would be doing a lot of adding, whatever. Okay? So again, it doesn't matter sometimes which one you use, but it's quicker one way over the other. Alright, let's look at our next little part of this. This is still the same thing, so converse of the triangle proportionality theorem. In math, converse just means you're going the opposite way. So, if a line separates two sides of a triangle, into proportional segments, then the line is parallel to the third side. Right, so up there we had like, oh yeah, right, I know it's parallel, and now are they proportional? Here, if you know they're proportional, then you can say they're parallel. Okay, so it's just backwards. So a triangle DEF, EH is 3, put a lovely 3 there, HF is 9, 2, and 6. So it's asking me, are these two lines parallel? Okay, so I'm still going to go down my line, so I have 9 over 3, and I want that to be equal to 6 over 2. Again, here I'm not solving for anything now. I have all my numbers. I'm just checking if this is true. Well, 9 over 3 is 3, and 6 over 2 is 3. Check. Right? So yes, DE is parallel to GH. Line DE, line GH. And that's it, okay? So it's just good to know that it also works going the backwards way. All right, go ahead, turn to the next page. Oops. We are now looking at our triangle angle bisector theorem. Okay. And our triangle angle bisector theorem states an angle bisector in a triangle separates the opposite side into two segments. That are proportional to the other two sides. So I got an angle bisector in a triangle separates the opposite side into two segments that are proportional to the other two sides. So let's go through this. What does that mean? So we have our angle bisector. I know this is an angle bisector. An angle bisector cuts an angle in half. So since these are exactly the same, right, it's showing us those little congruent marks. This is an angle bisector. So the easiest way I feel to like set it up is to start at where your angle bisector cuts and go over and over. Okay, so you're back. So you kind of make that little angle. And so this is telling us MK over, sorry, I was going to write M again, but there's no M there. And the side M to K over the side K to J is going to be equal to, right, again, start here and go over and over. So ML over LJ. Okay. So again, another way of just knowing that when segments are proportional so that we can set up that proportion. So example 3. find the value of x, right? Well, here's my angle bisector. So I'm going to start here where it bisects it and go over and over. So that's 4 over x. Start here and go over and over. 6 over 13. So 13 times, or 4 times 13 equals x times 6. We have 52 equals 6x. And a divide by 6 to cancel that out. And then 52 over 6, we're just going to leave it as 26 thirds. Again, this is not a real world problem, so we don't need to write it as a decimal. Alright, part B, same type of thing. Here's my angle bisector. Now we have to be careful, because if I start here and go here to here, I don't know what this side is. I know the whole length is 20, and I know I already have x here, so I want to know what's left on the other side. So I started with 20, but I've already used x. Okay, so it's 20, take away x. So I'll have 20 minus x over 11. And then here and here, I'm going to have x over 14. Make sure we have parentheses. When we cross multiply, I have 20 minus x times 14 equals 11 times x. 14 times 20 is 280 minus 14x equals 11x. Since I'm subtracting this 14x, I'm automatically going to add this 14x. Also, my only constant is over here, so it's easier just to move that one over. These cancel. 280 equals 11 plus 14x is 25x. Getting rid of that 25. They cancel. X equals 56/5. Again, these proportion parts we know how to do. The tricky part is, again, setting them up, since we've been doing proportions for over a week, right? So, that is it. I'll see you guys tomorrow.